Welcome to this tutorial on complex numbers in NumPy. In this video, you'll learn how to create and manipulate complex number arrays using NumPy's powerful array operations. Complex numbers are essential in many scientific and engineering applications, and NumPy makes working with them straightforward and efficient. Let's start with the basics. A complex number is written as z equals a plus bi, where a is the real part, b is the imaginary part, and I represents the square root of -1. The real part is the component along the horizontal axis, while the imaginary part is the component along the vertical axis in the complex plane. Python provides two ways to create complex numbers. The first method uses the j suffix, where you write 3 plus 4j to create a complex number with real part 3 and imaginary part 4. The second method uses the complex function, where you pass the real and imaginary parts as separate arguments, complex of 3, 4. Both methods produce the same result. NumPy allows you to create arrays of complex numbers easily. You can create a complex array from a list by passing complex numbers directly to np.array. For example, np.array with 1 plus 2j, 3 plus 4j, and 5 plus 6j creates an array of 3 complex numbers. Alternatively, you can specify the d-type parameter as np.complex128 to convert regular numbers into complex format. Once you have a complex array, you can access its real and imaginary components separately. Use the .real attribute to extract all the real parts as a new array. Similarly, use the .imag attribute to extract all the imaginary parts. These attributes make it easy to work with individual components of complex numbers. NumPy provides several functions specifically for complex numbers. The np.abs function calculates the magnitude or absolute value of each complex number, which represents its distance from the origin. The np.angle function returns the phase angle in radians, and np.conj computes the complex conjugate, which flips the sign of the imaginary part. Complex arrays support all standard arithmetic operations. You can add two complex arrays using the plus operator, multiply them using the asterisk operator, and divide them using the / operator. NumPy handles the complex arithmetic automatically, applying the appropriate mathematical rules for complex number operations element-wise across your arrays. Let's recap what we've learned. Use the j suffix or the complex function to create complex numbers in Python. Access the real and imaginary parts using the .real and .imag attributes. NumPy functions like abs, angle, and conj work seamlessly with complex arrays. And all standard arithmetic operations are fully supported for complex numbers. With these tools, you're ready to work with complex numbers in your NumPy projects.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.